So for the legs, we'll start with a line. Going to make a line, put it like this, and we'll change the direction to -1. And the length, I don't know where we'll be, let's say 0.1 to start with, 0.15. And we'll keep this at 2 points. So what we'll want to do is grab the same points that were used here to create those struts, and we're going to copy something onto them. So we will use a copy 2 points, and we'll start by grabbing the poly extrude and piping that right into here. And the direction changes because we don't have any attributes existing on here. So let's put some attributes down. I'm going to do this slightly differently. We're going to do something called a polyframe. And what a polyframe will do is give us attributes that come in from the edges of the geometry. It's going to convert some stuff. It's easier to take a look if we do something like turn on our normals here. We can see that it's aligned normals in one direction like this. And I want actually to change this. I'm going to turn that off, and we'll change normals to that. And now we see that our normals are actually pointing inward. It's kind of averaging the two edge normals to give us this direction. But I also want to set an up vector too, which is going to point up. So we're going to change that normal name here to up. Now we can't visualize this right now, but let's go ahead and do that. We'll hover over I, and for up here, we'll just click that. And now we've got a visualization of where our normals are pointing and where the up vector is pointing. Now let's take a look at the line. It's pretty good. Now we can't really tell what the normals did for us, but we will once we put a transform stop down. So if I put a transform here and we rotate by the X value, you can see what happens is, because of our normal alignment, we're basically rotating this around the geometry as it gets copied there. And so we're getting that spread for us with this simple control here. Now I'm going to color that blue just so that we can find that easily. Okay, so let's go ahead and sweep this. So we'll put a sweep here. We have an error because we don't have anything coming in here, but we actually don't need to. I can change this to, instead of using the input cross sections, which we don't have, we can just say, give us a round tube. And then we can take the radius and bring it down however we need. We'll change the columns to 24. And we will, actually, let's use a single polygon here for our edges, and we can turn off our normal display there. Okay, that's going to work pretty well for the most part. However, we'll merge this together and see some of the issues we have. We'll call that legs, and we'll merge that in. And let's change the order. Okay, so our first big problem here, we can see that, number one, we don't quite line up here, and we've got this big gap. So we need to solve this problem. Let's take a look at how we're going to do that. We're going to go here after the transform, and we'll end up basically slicing this and then copying it on. But we need a way to identify a couple things about the top caps here. So what I want to do is figure out what the group is for that. I'm going to go back to our sweep, and we'll make a group for the top cap, and we'll make a group for the bottom cap here. So we'll use a group here, and we'll call this top cap. Turn that off, and we'll find that just by grouping by normal. And we'll say if it's pointing up with a spread angle of something like 20, you are a top cap. And we'll do the same thing for bottom cap. Change the direction. And we'll change the name. That's bottom cap. Okay, so what we're going to do is find out what is the highest point of our top cap here. And we will, or actually, what is the bottom point of our top cap? And we'll slice this along that line there. So we'll delete this. We'll make a kind of separate stream to do this. We'll delete everything that's not the top cap. And let's make sure that this is set right. There it is. Okay. All right. So let's find out here where we need to slice this. To slice this, we can use a clip. And we'll change the primitives here to below the plane for which ones to keep. And you can see that there is an origin that we can adjust. What we need to do is find the bottom of that cap there. So it's really simple because we have this stored over here. We can just query that with a bounding box. So we can say bounding box and then point to that delete and then get the y minimum. So d_y min. And now we've sliced that right there. We need to cap that again. So we'll use a polycap. And now that's capped. Now I want to round out the bottom there. So we'll use a poly bevel to do that. Now that's doing everything. I'm going to change the group here to bottom cap. Make sure I use primitives. We'll keep this at round, and I'm going to bump this up to, we'll say 8. And to get a nice perfect half circle like that, what we'll do is we will link that to the radius here. So we'll copy our radius from our sweep, and we'll paste that into the distance there. So now as our sweep goes up and down, that's going to stay just like that. Now that gets wired back into here, but we still have another problem, which is that there's a big gap here. So we need to move this all the way up so that it sits at 0. So what we'll do, and not just that, we also need to move the center point here. So we can see just moving this up isn't enough. We need this whole circle to be centered there. So we still have nothing that we can use here. We're going to need to actually extract the top cap off of that. So we want to make sure that we have a group for that. So we will click this to get a patch group. And we'll do something similar where we delete everything that's not that patch. So let's go find patch and delete the non-selected. Okay. And now what we're going to do is do some stuff to offset that. So we're going to transform. This time we'll use a centroid expression. So we'll start with y here. So we'll say centroid, and we'll point to that delete number 2. And d_y. Now that's going to move it down. We actually need to negate that to move it up. And we'll copy this and do the same thing for x and z. Make sure to change x here to x and z to z. And now we've placed that right at the origin there. So now when that gets copied here and merged in, the legs sit exactly where they're supposed to sit. And we still have the flexibility here that we can change this. So looking good here. Let's say it's about 20. And the distance, who knows? We'll say 1.4 or 0.14. And let's go ahead and clean this up here. So we'll grab all of those and label them. All right, that's it for that part of it for now. And we'll go ahead and look at how we can tackle these cross beams. All right, for the crossbars, we're going to start with this line that we had for our legs. I'm going to turn on my point display here. And we'll add 2 little insertion points in here, 2 little anchors. And the way I'm going to do this is with a node called a carve. So we'll take carve number 1 and we'll put that here. And I'm going to change this to extract point. And what that will do is it will allow us to extract a point along that curve. So we'll say one point is at 0.5, and we'll have another point at 0.6 or 0.4, who knows where. We'll just keep it like that. And we'll group these. So this is a point group, and we'll call that crossbar anchor A. Copy paste that, and this will be crossbar anchor B. We'll merge these together. And that will be grouped into here before we do our transform. It'll be merged in, so we'll put a merge here and just pipe that into here. Okay, so now after our copy to points here, what we should be able to do is delete everything that wasn't part of that. So we'll pipe that right here, and we'll change this to points, delete non-selected, and we'll go and find our crossbar anchors. All right, now that gives us our points. Now what we need to do is convert this into those little crossbars. So let's take a quick look at our reference here. And what we can see is that the higher one here is the one going on the longer side. So let's go ahead and make some lines for these things here. So this is our longer side here. And what we'll do is go into points mode, and I'm going to turn on our point display. And we'll go ahead and use an add SOP here. So this is going to let us create polygons out of points. And I'll put that down here, and we will do a polygon, which is going to go from, let's say, from 4 to 2. So type 4 and 2. And now we have one, just like that. Now we need one that goes from 6 to 0. So click plus and type 6, 0. And let me just make sure that's right, 0, 6, okay. Next, we're going to need 1, 3, and then 7, 5. So 1, 3, 7, 5. Okay, this gives us the beginning of our crossbars, and we'll want to sweep that as well. So we'll make a sweep, put that down, and change this to round tube. We're going to enable a single polygon cap, change columns to something like 24, and the radius needs to come down significantly. Let's say something like that. I'm going to go back into primitives mode here. And I want to group this stuff together. We're not quite done here, but let's group that. We'll label this as well, and I think we'll need some normals on this. Put a normal node down. And we'll merge this in with everything else. Now, this may look okay, but what we know is that the crossbars are actually penetrating through here. So if I go into wireframe, we can see that they're penetrating in there. And that may work. It's not quite proper to do something like that. So let's go ahead and Boolean these together and cut the legs out of the crossbars. We will use a Boolean subtract. We'll put that right there, and we will subtract out our legs. Now, if we look in wireframe mode here, you can see that we've successfully clipped the crossbars. Now, I'm not going to do any little bevels here. We could if we wanted to, but we'll keep this fairly rough for now.